Hi, everyone, and welcome to Discover Engineering's Chats with Changemakers. I'm your host, Kavya, and I'm a high school senior from New Jersey. And every month, I welcome a different guest from the engineering community. Today, I'm chatting with Leah Baker. Leah is a chemical engineer at Cargill and a leader at Society of Women Engineers. And I'm super excited to chat with a fellow SWE member because I'm also a member of Society of Women Engineers' high school leadership program. So, Leah, welcome. Thank you so much for joining us today.
Absolutely. I'm so honored to be invited. Can't wait to, chit chat and
Me
see
too.
what
I'm looking
you
forward
got
to
for me.
this. So I'm going to be asking Leah a few questions to get to know a little bit more about her. And you can ask your questions too by typing them in the Q&A box below. And we'll save some time in the end to get to as many as we can. So without further ado, let's get started. First of all, Leah, I'm incredibly excited to hear that you're involved in Society of Women Engineers, or it's also called SWE. And let's start at the beginning. So how did you first get involved in SWE?
Yeah. So I first came across SWE right before my very first day of college at the University of Minnesota. And I was super duper terrified right before going to school. And I had lots of questions about engineering, wasn't sure what I was going to study. And I went to the state fair. That's a big deal in Minnesota. I'm from Minnesota. I live near Minneapolis. The university is near Minneapolis. We have a big state fair every year, lots of food on the stick. But anywho, right before going to college, I went to the state fairs to, hang out, see the sights with my dad like I do every year. And we went to the University of Minnesota building. And who happened to be tabling but the Society of Women Engineers? So I just kind of stumbled upon them. They were doing a demo with like little robots. It was pretty neat. But I was able to ask them all the different questions about different majors, what classes to take. So before I even stepped foot, yeah, on campus, I had a support system right there, and so I was hooked immediately after I just kind of walked into them, and then I joined SWE, and the rest is history.
That's awesome. And I also got involved in SWE in my freshman year of high school. So it was also in the beginning. I did their high school leadership program for girls, also known as Sheila. And like you mentioned, that was like my first introduction to the SWE community. And this year, SWE Next, they named a couple of students as global innovators. So I also joined that community. And it's just been great meeting so many amazing girls and women in tech. So I'm really excited to have this conversation with you. And yeah, let's get into your career path. So, like, what drew you to the field of chemical engineering, and how did your college experiences influence that direction?
Yeah, so I wasn't always interested in chemical engineering. I came across that in college, a little bit before I had heard about it, but I wasn't like going into school dead set on chemie, as they say. So I went into college thinking that I wanted to be a biomolecular engineer. So I wanted to study the smallest things possible, molecules and things in your body and actually do engineering to shape molecules and make them do what I wanted. That's what I thought. So I started out with that in mind, and I took some intro level classes about biomedical engineering. So engineering different, like if you're going to build a new hand, that would be biomedical because there's like a medical part of it. So I took some of those courses. It was interesting, but I ultimately really loved my chemistry classes. The periodic table of elements. I'm very fond of the table. And as I went a little bit further into my college career, I was sad that I wasn't going to have very many chemistry courses in my calendar. So I knew I needed to switch things up. So I went into chemical engineering so I could take chemistry and do the large scale problem solving that engineers do. So I kind of combined the two. And that realization also came not just with the classes, but I did have an internship at a medical device company in Minneapolis called Medtronic. They make a lot of pacemakers that will like make your heart beat like consistently. It kind of regulates your heart. Very, very important medical devices. They do a lot of other stuff, but I worked there for a summer, so I got to try biomedical engineering. And I liked it, but I also was most excited about the chemistry side of every project I was on. So that was just another experience that pushed me towards chemi.
I think it's interesting how you mentioned you were initially in the biomolecular path, and even though you decided to go with chemical engineering, a lot of that experiences and knowledge kind of transferred over. So it was great to hear about that. And so now, could you please provide an overview of Cargill and your role in that company?
Yes, absolutely. So Cargill might be the largest company that you've never heard of. We go between one and two on the list, but I think we're currently the largest privately held company in the world. And essentially, we do a lot of food and food ingredients. So everything you've eaten today probably has a Cargill product in it, whether it's some sort of meat from Costco or something like that, or all those weird ingredients that you can't pronounce on the back of the Cheez-It box. That's usually us. But we also sell salt. So if you like Lay's potato chips and you like a salty snack, you have us to thank. We also do, I mean, soybeans and corn. And when you look out on a farm field, that's a lot of us as well. So food and agriculture is mainly what we do. But what's kind of unique is that I don't work in food, and I'm not super familiar with food either. I work for the bioindustrial business of Cargill. So you have all this plants and agriculture and food, but you can also take those ingredients and do other things with them in different applications. So, and in industrial applications, as we say. So we have a wax business. We put those materials into plastics and asphalt on the road. Foam is one application space that we work in, and I could go on and on, but I work on kind of the chemicals side of Cargill, not the food as much.
That's a perfect segue to my next question, actually, because you mentioned working on wax and glycerin product lines. So,
Mhm.
what are some real world applications of those products beyond what you had just mentioned?
Yeah, yeah. So in the bioindustrial business, like you mentioned, I specifically focus on wax and glycerin. So the main things that we do with wax are candles. And it's that time of year, keep your eye out. If your candle's around, if it says like a soy blend, maybe it has our product in it. So we do a lot of candle wax, but you can also use wax for other applications like coatings for packaging. Um, yeah, you'll see it around, or like coating on cardboard and stuff if you need it to be water resistant. And then for glycerin, if you're not familiar, glycerin is clear goo that happens to be a byproduct of one of our supply chains. And you probably eat it all the time in different candy, different chewing gums. So there's a couple different, so you've got food for glycerin, but there's also industrial applications. Like they'll spray, like they de-ice airplanes with propylene glycol. That's another something made from glycerin. And then also in like personal care. So your shampoo is kind of gooey and soft, and that has glycerin in it as well. So there's kind of a variety.
Thank you for sharing that. I think it's clear that Cargill has so many different research areas and streams they're kind of in. So
Oh yeah.
that's great to hear.
You name it, we're probably involved.
And now I want to get into technical details of one of your past projects. So, just to give a little bit of background to our viewers, immersion cooling is a process that enables servers and heat intensive equipment to operate efficiently. And you've designed data centers to test this critical method. So, I was wondering, how is your work different from the existing research out there on immersion cooling?
Yeah, so before I worked on glycerin and wax, I used to work in our lab. And one of the projects I worked on, like Kavya said, was immersion cooling. So cooling down computers as best you can. And maybe you have your laptop on your lap right now. It might be warm, but computers like to be cold because I don't know. They do best that way. I'm not an electrical engineer. I couldn't tell you the details. And the best way to cool something down is by having a lot of material close to it to pull away the heat. So using a liquid does a better job than air. where because there's usually a fan on the back of your computer. So we're trying to use liquid to cool stuff down as best as possible. So without getting too technical, it's our research is different than traditional immersion cooling fluids because ours are bio-based. We use a lot of different soybean oil derivatives. It's like vegetable oil that you might make cookies with. It actually works really well to cool down computers. So that's kind of where we stand out. Some other competitors are, it's like a synthetic, or you have to run a chemical reaction to get to your final product of your immersion cooling fluid, but not us. It's not as complicated on our end. So we're trying to use bio-based materials that are not hazardous when you spill them. You could probably technically eat it. We don't recommend that, but that's kind of how we stand out.
And going back to that idea of using bio-based materials, I did want to get into how has your line of work changed with the demands for sustainability?
Oh yeah, I it's changed. I mean, my career hasn't been that long, right? I graduated from college just a year and a half ago, so I haven't seen a lot yet, but there's certainly much more interest in green chemistry or doing chemistry in ways that are not as harmful to the earth. And so I see a lot of pressure from customers specifically wanting more bio-based or green, earth-friendly solutions as opposed to petroleum-based or what have you of the centuries of technologies that we've been practicing for so long. So that's kind of the shift, just towards sustainability, really across chemical engineering, because there's a lot of different applications in chemical engineering and different ways to be more sustainable, whether it's using less energy, less greenhouse gas emissions, or just starting from a bio-based material. You could go on and on. So,
And we actually have our first audience question from Mr. Turner's class in Pennsylvania, and they wanted to know what is the most challenging project you worked on and why?
that's a great question. Hello, all of you out there. The most challenging project I worked on was actually in college during COVID. We were doing a lab experiment on like a big piece of equipment, like for lack of a better term, it was just a reactor, and we were trying to get a product in and a product out, or a reactant in and a product out. And the challenge was we had a team of three. The equipment was upstairs, and only one person could be upstairs at a time because of COVID. We couldn't be near each other.
Mhm.
And there are some systems in process chemistry and in chemical engineering where you can't have your phone nearby because it's an explosion risk. So they'll say it's an explosion safe room. You can't bring your phone in. So we couldn't record anything or take pictures. So it wasn't even a technical challenge at that point. We needed to figure out how to communicate from downstairs to upstairs and relay data and what they needed to do step by step to get the product out. And we needed to write our paper all separately. So that was kind of an interesting one, but we got it done.
Yes, and definitely. I think the pandemic presented a lot of logistical challenges, but it's great to hear how you were able to overcome that. And now, this is one of my favorite questions. In what ways do you think your job encourages you to be a change maker?
Yeah, absolutely. So I guess I didn't mention it before, but so I'm a chemical engineer, right? But I currently sit on the sales team. So I talk with customers about our products and the science behind them and help them sort out their problems. And I think my job specifically positions me to be a change maker because I know about the science. I love science and engineering, but I also have to tell people about it. And I feel like I get to bridge that gap between people who don't come across science all the time and aren't constantly thinking about, oh, what is my phone case made out of? How does my car stick to the road? Like the, science themed thoughts that I might have. But to kind of bring science to new audiences is a skill that I think I've developed in my job and something that my job enables me to do and get better at all the time.
And I think that definitely connects with our conversation today because we're also trying to share the possibilities in engineering with more people. And thank you for also emphasizing communication, because I think that's like another important skill for engineers of the future. And what is one future trend or development that most excites you in your field?
Oh gosh. I mean, I think the most exciting pieces to me go right along with sustainability.
Mhm.
Um, and one thing that excites me that I think I touched on a little bit earlier, but is how excited my customers are about it. And like, not that my company is not, but like they're coming to us asking for the better solutions that are more sustainable and green. And business often drives change. So when you have people asking for it and willing to pay for a green solution, I think that's really exciting. Because it takes a village to really make change in the environmental space. And sometimes, you have more scientists in the room who really want to push it, and you have to get the whole crowd interested. And I think we're really shifting towards bigger change on the other side. So, not super specific, but it excites me.
Definitely. And going back to Society of Women Engineers, so you've written a book with them about real engineers, and that's pretty amazing. So can you please tell us more about the book and why you wrote it?
Absolutely. So, with the Society of Women Engineers, I lead the outreach committee. So,
Hmm.
sharing resources to share science to as many people as will listen. So, we thought this was several years ago before I was even involved at the society level that I am now. They decided to write this book. And essentially, it's a collection of 20 or 25 just stories of different women in engineering and science, and where they started, their stories of growing up, how they found science, and what they do now. So you can really have this like personal experience with someone and learn from them without, having to give them a call, which I doubt we'll have their contact information in there, but you
Yeah.
can really get to know somebody and learn all the different routes through STEM, just through this one book. And we also have some pretty cool collaboration with our illustrations. We have some engineers who really like to draw. And they have like a cool program that like it's a whole thing. You'll have to check it out once it hits the presses. But it's been a really neat collaboration of different skills and interests. And it should be, we think it's going to be ready to go next summer. So summer 2024, you should be able to find Society of Women Engineers book on engineers. So,
Definitely. I'm going to be checking that out for sure. And I hope some of our viewers also do so because role models are super powerful. And I was actually wondering, did you have any mentors or role models who inspired you to pursue the path that you are on today?
yeah, I certainly did. I think I when I was before I went to college, I didn't have any strong role models in engineering that were women. So that's part of why I do so much outreach now to, create those connections and be a role model. I think Mrs. Frizzle of the Magic School Bus was a pretty good mentor, though I don't know, this might be an older show of the Magic School Bus. Yeah, but she was certainly a fierce woman in STEM that I could look up to. And we had some family friends who were engineers, so I knew what engineering was, but I didn't have a ton of people to ask questions of, and really explore what I was looking for. But when I went to college, I connected with a grad student, who is still my mentor today, and I, ask her all sorts of career questions and just questions about what it's like to be a woman in STEM. So hunt down Dr. Mulaney Young. Um, she's she's my favorite. But
That's great to hear how you had so many role models, some of them in real life and some of them fictional, but still that makes all the
yeah.
difference.
Mm-hmm.
And thinking of the students joining us today and in the future, what is one piece of advice that you would want to give to your younger self?
Yeah. I mean, I would probably say like I was really scared when I was going into STEM and investigating. And I knew what I wanted to do because it made me so excited. But I was scared that I wasn't going to be able to do it. And there was just so much stress. And it felt like, okay, I can get through this math class, but what about the next one? And there was like this weird black box of college that I didn't understand. I was like, what the heck is multivariable calculus? Like, I don't know that I can even understand that. And I think looking back, I would tell myself, like, hey, I have the passion, you have the drive, it's going to be okay. And it's not always about your specific scoring best on the science test or the math test. I think it's really about like your passion and what gets you excited every day. And I always loved creative problem solving, and that's what I chase today in different roles in as an engineer. Um, so that's probably what I'd say. I'd probably be like, wow, you're shorter than I remember if I got to meet my younger self as well. There'd be other takeaways too. But
Find your passion and follow it. I love that. And we have another audience question, a middle school class in Virginia, and they wanted to know what is the starting salary of a chemical engineer?
yes, so there's kind of a variety depending on what industry you go into. I would say on average, maybe 75 to $80,000 a year. And like I said, that can shift if you go into graduate school, it might be lower to start. Or if you go into, say, oil and gas, that can be more lucrative if you're looking for that. But that's roughly what I would say. And with inflation, who knows?
Yeah. And what is one skill that technicians and engineers of the future should develop, in your opinion?
Ah, geez. Let me see here. Um, I took notes earlier. Okay, yeah, I'm gonna circle back a little bit to like why I got interested in pursuing engineering is the creativity side, I think, is something that can get lost, especially through college when you're so focused on or even in high school when you're so focused on finishing those STEM courses. I mean, innovation happens when you step outside the box, right? So I I love working with teams of people who have totally different perspectives from me, different experiences and different ideas. Because I mean, I mean, if you're making a batch of cookies and you need a variety of ingredients to make something really great. So I hope that we can all really think big and not be limited by who knows what, but be really creative and imaginative in making the better solutions for tomorrow.
Awesome. And we have a question from Ryan. How do you recommend learning about different engineering fields in middle and high school?
Learning about different fields. One thing that I often, well, there's a ton of resources out there now. I feel like, I mean, you're listening into Discovery's chat. This is an incredible way to learn more. But if you really want to dig in and go a little deeper, um, well, I'll back up a little bit. I don't know if any of you have watched Nova on PBS. It's just a science show on, the public broadcasting station. And that show played a big role in me deciding to pursue engineering. I was just so excited by all the different people and work. And like every time I hear the theme song, my heart rate like still increases. It's like, oh, what am I going to learn? So if you don't have the resources to go out and do something hands-on, I recommend checking out that show and see if something speaks to you. As well as Discovery, clearly, lots of opportunities, but also as a student, you have immense power. Anyone that you want to reach out to, you can probably find their emails or ask an adult to maybe help you find them on LinkedIn. Not sure if you're found that resource yet. I know you're not probably networking yet. But if you reach out to any professional, any scientist or engineer, maybe there was a lab you really want to tour. I have never heard someone say no, especially when you are in high school or middle school or even younger. You have some crazy power if you're not afraid to ask. So there's some pretty cool opportunities that you can create for yourself as well as find some existing ones.
Definitely. And we live in such a digitally driven world, so everything's just one click away. And I think that works well for a lot of students who want to explore more.
Yeah.
How do you not only find your passion, but keep it ignited? I know we talked about this briefly before, but kind of wanted to hone into that.
Yes, I mean it's very hard to find your passion. There's a lot of
Yeah.
mistakes that can, or not mistakes, you know, but like you try something and then maybe it's not what you thought. And I'd say I am still chasing my passion every single day, trying to figure out what I really want to do. My career hasn't been that long. But just trying as many different things is always helpful for that. But how I really keep it ignited, especially just for STEM, is outreach. I absolutely love, like, going to the science museum, setting up a table, talking about, how to make slime, how to build a catapult, different little challenges just that are engineering based. So sharing science and STEM really gets me excited, and makes me want to continue to chase different answers. So outreach.
Awesome. And now we're going to go into some fun questions. So the next question is a fill in the blank. I am a, and then you can finish that sentence with the one word to describe yourself. And I wanted to know why you chose that word that you're going to tell us.
Oh, geez. Just down to one. Let's see. I'm gonna go with goofball. That's probably where I'm gonna land. I could say learner or something like, you know, professional, but I think that probably describes me best and what makes me like excited to do different things. And be creative piece is like,
Yes.
don't typically take things too seriously. And I think that's helpful in STEM when there can be so much pressure, and trying to do different things. And when you're often the only woman in the room, using humor can be a great way to, break boundaries, and build relationships really quickly. So I'm kind of proud of the fact that I like to goof around and learn about people and have conversations and not be too afraid, even when it can be a high stress situation sometimes. So,
And if you had a time machine, what time period would you visit and why?
oh goodness, Kavya, I looked at this one and I thought about it. I don't think I ever came up with a good final answer. I mean, I'm really into Hamilton, the musical, so they're in like the Revolution, so maybe there. But I'm also concerned about not having like modern showers and medicine. So maybe maybe not so far back. Maybe I'd like to go to like a dance hall with my grandparents in like the 60s or something. I don't know.
I mean, you could bring modern chemistry back to the times of the revolution for medicine.
Now there's an idea. Let's go. Let's book a trip.
Sounds good to me. What do you like to do for fun outside of work?
Yeah, I do a variety of things. I play softball. I ride my bike a lot. I live in Minneapolis, so it's pretty
Mhm.
cold and snowy here. So I mean, I love sledding, building snow forts, and cross country skiing is really big here. I know that's not popular everywhere, but that's something I like to do. And I like to craft, just make things out of nothing, kind of the engineer within me. But I'm usually up to something, I can tell you that.
And last but not least, in your opinion, what is the coolest element in the periodic table?
Uh, yes, I've had this opinion for quite a while now. I've
Mhm.
always been a big fan of hydrogen. It is the most abundant element in the universe, and it's been my personal favorite for since I don't know, maybe middle school time frame. But it's just involved in everything. It's not usually on the sidelines. It's often responsible for things going on. It's just, in the thick of things. So I like hydrogen, and it can just be a proton. I could go on and on, but
And that's the time for questions we have today. But Thank you so much, Leah, for joining us. It was great to hear about your work with Cargill, your journey in Society of Women Engineers, and most importantly, your passion for creative problem solving and how that's kind of led you to where you are today. And I definitely can say that from this conversation, I learned to keep my paths open and to always be excited about exploring and trying something new, because that's really what science is all about. So thank you so much for joining us today.
Absolutely. And thank you. So excited to be here.
Definitely. I'm sure all our viewers had a great time hearing about your experiences. And I also want to thank our sponsors, Bechtel, NCEES, and TE Connectivity. And a huge thank you to all of you for tuning in. To learn more about chemical engineering careers, you can check out Discover Engineering's website at discovere.org, and you can click on the STEM career section to learn more. And be sure to join us for our next episode of Chats with Changemakers on Thursday, December 7th. We will be meeting our new guest, a member of SME, which is the Society for Mining, Metallurgy, and Exploration. See you next time, and thank you.